Hello and welcome students. Hope you all are studying well and referring the video lectures thoroughly. Till now we have completed two methods of correlation, that is the first one, that is scatter diagram method, and the second one, that is Carl Pearson's method. Now in this video lecture I am going to start with the third method of finding correlation, that is Spearman's rank correlation method. As this method was suggested by the statistician, that is Charles Spearman, this method is given the name that is Spearman's rank correlation method. Now in Carl Pearson's method we used to study the relation between two quantitative variables. It means suppose height and weight of students or marks of different students in two different subjects. That type of relation we used to study with the help of Carl Pearson's method. In this method we are going to study the correlation coefficient between two qualitative variables. Again I am repeating, in the last method we were studying the relation between two quantitative variables which can be measured in numbers. Over here we are going to study the relation between two variables or two attributes or two characteristics which can be measured, which cannot be measured, or they are called as qualitative variables. For example, beauty, honesty, morality and so on. These type of attributes that cannot be measured in numerical figures, that are to be found out the relation between two variables by this method by giving them ranks. That is called Spearman's rank correlation method. I am reading the meaning of it. The correlation coefficient computed using ranks of two qualitative variables. It means word qualitative is important over here. That is the basic difference between the two methods, that is Carl Pearson's method and rank correlation method. Over here, qualitative variables as suggested by Charles Spearman. Earlier I had said that this method was suggested by the statistician, that is Charles Spearman. That's why this method is given the name, that is Spearman's rank correlation method, is known as Spearman's rank correlation coefficient. Here two examples are given to you. First one, the study of relationship between two attributes, honesty and punctuality, for a group of persons by ranking them according to their proficiency. Means according to their proficiency in their work, the group of persons working in a factory, their honesty and punctuality are being measured. The relation is being found out of the two variables, that is honesty and punctuality, according to their proficiency by this method, that is Spearman's rank correlation method. The next example is given, the study between the judgments of two judges in a beauty contest who rank the contestants according to their performance in the contest. It means there are two judges who are giving the judgments and in a beauty contest, and they give the judgments on the basis of giving ranks. They are giving the ranks, who is having the maximum performance done in a better way will be given the first rank, whose performance is little bit deteriorating in the first one will be given second rank, and so on the third rank. So they are given the ranks on the basis of their performance by the two judges. So that type of relation between the judgments of two judges on the basis by giving them ranks to all the contestants, that method is known as Spearman's rank correlation method. Now after understanding the basic concept or the basic difference between both the methods, how to do the practical sums by utilizing this method, that is Spearman's rank correlation method. The only one basic formula is to be followed or remembered over here. In Carl Pearson's method there were many alternative formulas that we were utilizing to find the correlation coefficient. Over here there is only one basic formula that you have to remember, that is R is equal to 1 minus 6 sigma d square upon n into n square minus 1. 1 is separate, it is not coming in numerator or denominator. 1 minus 6 sigma d square. D means difference between, what is D? D is difference between Rx minus Ry. Difference between Rx minus Ry means difference between rank of X and rank of Y variable. The difference between the ranks given by the two variables is called d, and after getting the d we have to find out d square. It means the sum of the deviations of the difference between the ranks of the two variables. So that is the main important point, or the main value that you have to find out, that is sigma d square over here. And n means you are knowing it very well, that is number of observations. So this is the one important and basic formula that you have to remember, that is 1 minus 6 sigma d square upon n into n square minus 1. Now after understanding the formula to find the correlation coefficient by Spearman's rank correlation method, let us move on to the practical sums. In your textbook you can see exercise 2.3, that is totally based on this method, that is Spearman's rank correlation method. So I am starting with the first sum of exercise 2.3. Let us read the question. 6 companies are ranked by the two market analysts on the basis of their growth in the recent past. Company A, B, C, D, E and F ranked by analyst 1 and ranked by analyst 2 that are given to you. So over here in the question you can see that the company's name are given to you, that is from A to F. So total there are 6 companies data that has been given to you, and the ranks are given to you directly. In the next sum which we will be studying, the ranks will not be given to you. You have to give the ranks to the two different variables. This is the initial question. That's why the ready-made ranks are given to you. So no need to find Rx and Ry. Rx means rank of variable X and Ry means rank of variable Y. Now the ranks of variable X, that is 5, 2, 1, 4, 3 and 6. And rank of variable y, that is 6, 4, 3, 2, 1 and 5. This much data of 3 columns that is already given to you in your question. Now the main important point starts over here, that is D. That I already explained the formula what is D. D is equal to difference between ranks of two different variables, that is X and Y. Over here Rx and Ry, so D is equal to difference between these two variables X and Y. So 5 minus 6 is equal to negative 1, 2 minus 4 is equal to minus 2, 1 minus 3 is equal to minus 2, 4 minus 2 is equal to positive 2, 3 minus 1 so plus 2, 6 minus 5 so plus 1. After finding the D, we have to do the square of it, that is D square. So D square means minus 1 square so it will come plus 1, minus 2 square so it will come plus 4, minus 2 square again 4, 2 square 4, 2 square 4 and 1 square it means 1. So we have to do the total of it, because the only value we need in our formula, that is sigma D square. So over here we have to do the total of D square, that is sigma D square is equal to, you can see 4 times 4 is repeated, so 4 4s are 16 and plus 1 and plus 1, so it would come 18. Sigma D square value, that would come to 18. After getting that value, you are again revising the formula, that is R is equal to 1 minus 6 sigma D square upon n into n square minus 1. 1 is separate, it is not coming in numerator and denominator. So 1 minus 6 sigma D square value we have already found out, that is 18. So 6 into 18 upon 6 into 6 square minus 1. Now 1 minus 6 into 18, that would come to 108 upon 6 into 6 square means 36. 36 minus 1, so that would come to 35. 35 into 6. 35 into 6, that would come to 210. So 1 minus 108 upon 210. So first of all, you don't have to find the LCM, because this one is totally separate. So first of all, you divide these two values, that is numerator and denominator. So by dividing 108 by 210, you will get 0.51. That you have to subtract from 1. So 1 minus 0.51 is equal to 0.49. Over here also again revising the properties of correlation coefficient, that is value of R can never be more than 1. That rule or that property is applied for all the three methods of correlation coefficient, that is for scatter diagram method, the second one that is Pearson's method, and the third one that is Spearman's rank correlation method. moving on to the practical solution of fourth question of your textbook. That is the fourth question in which the marks of two different subjects are given to you, that is of mathematics and statistics. Find the correlation coefficient between the ability of students in the subjects of mathematics and statistics. Students, in the exam also in question it would be clearly mentioned to find the correlation coefficient by Carl-Pearson's method or by Spearman's rank correlation method. So no need of any doubt or confusion that in which sum which method to be applied. So it would be clear cut mentioned in the question to apply which method over there. First of all, let us read the question. The following is information is obtained by taking a sample of 10 students from the students of a science college. Students data will be given to you of 10 students, that is 1 to 10, and so the number of observations that would be n is equal to 10. Now marks in mathematics and marks in statistics that are given over here. You can see on the board I have written second column, that is marks in maths and marks in stats. Now marks in maths over here, in the previous first sum that we had done, the directly ranks were given to you. Over here only marks are given to you. You have to give the ranks. It means Rx and Ry value are not ready-made given to you. You have to find the ranks of variable x and you have to find the ranks of variable y. Okay, now over here you can see the highest marks. Naturally, those students who are getting the highest marks in a particular subject will be given the first rank. Then afterwards the second, third and so on. So over here also you have to see which student is getting the highest marks in particular subject, that is maths. So over here highest marks in maths that is secured by 8 number of student, that is 98. So you will be giving first rank to 98 marks. Then you have to observe the second rank, that is 90 marks, number 2 rank. Then afterwards 82 marks directly, so number 3. You don't have to make mistakes. See that any of the marks is not remaining in between, or you make a mistake in ranking the students. If you make mistake in ranking, then the entire calculation will go wrong. Even though you have applied the correct formula, your answer of correlation coefficient will come wrong. So be careful in giving the ranks. Now third rank, that is to 82 marks. Now the fourth rank, that is coming to 78. Fifth rank, that is 75. Then afterwards 75. Then sixth rank, that is really 65. Seventh rank 62. Eighth rank, that is 39. Then afterwards ninth rank, that is 36. And last, that is 10th rank, that is to 25 marks. Okay, now same way that you have given the ranks for variable x, that is marks in subject maths. Similarly, you have to give for ranks to variable y, that is marks in statistics. Over here, the first student, the student with highest marks, that is 91. So you will be giving one first rank to that. Then afterwards, second rank, that is 86. Third rank, that is 284, and so on. See that all 10 number marks ranking you should be giving. How many observations, that many ranks should be given. So no any mistake would be there in your calculation. After completing the ranking of the two variables, the next step that you are knowing it very well, that is to find D. D means difference between the ranks of the two variables. So over here 8 minus 10, so it would come to minus 2, 6 minus 8, so minus 2, 7 minus 7, 0, 2 minus 2, 0, 3 minus 5, minus 2, 5 minus 4, 1, 10 minus 6, 4, 1 minus 1, 0, 9 minus 9, 0, and 4 minus 3, it will be 1. You don't need to find the total of rank of variable x or rank of variable y or even of d. Only you need the total, that is sigma d square, that is the total of d square only you require. So no need to do the total of other columns other than sigma d square. Now finding the value of d square, over here d square means d multiplied twice. So 2 square will become positive 4, minus 2 square again 4, then after 0 will be as it is 0, again 0, 2 square means 4, 1, 4 4s are 16, 0, 0 and 1. You have to do the total of all the values here. It is very smaller value, so orally also you can do the calculation. 4 3s are 12, 12 plus 3, 12 plus 1 13, 13 plus 16 29, and 29 plus 1, that would come to 30. So sigma d square would come to 30 over here. And that is the only basic value that you have to find over here. Now placing that data in the formula, you are again repeating the formula, that is R is equal to 1 minus 6 sigma d square upon n into n square minus 1. So 1 minus 6 into bracket sigma d square, the value we have found out, that is 30. So 6 into 30 upon value of n, that is total 10 students data have been given to you, so n would be 10. So 10 into bracket 10 square minus 1. 10 square minus 1, you are knowing 10 square means 100, so 100 minus 1, it would come to 99. 99 into 10, it would come to 990. So in denominator it would come to 990, and in numerator 6 into 30, 6 3 is 18, so 180. So 1 minus 180 upon 990. With the help of calculator, do the division of the numerator and denominator, that is 180 divided by 990, it would come to 0.82. Subtract that value from 1. So 1 minus 0.82. So your answer, by mistake I have written over, your answer would come 0.18. So that is the end of the sum. So this sum is comparatively easy than the previous method, that is Carr-Pearson's method, in which we have to apply various different formulas depending upon the data that has been given to you. So comparatively this method is quite easy. Keep practicing from the sums that I have taught in this video lecture, and till then, that's all for today. Till then, goodbye, stay blessed.